All right, so today we're in section 1.2, solving multi-step equations. All right, so example 1, I need you to write down, okay, obviously title your notes example 1, and then write down this equation, 3x plus 15 equals 24. 3x plus 15 equals 24. What we learned with multi-step equations, you did learn this in 7th grade, is that so some of this might be a review, just a refresher, but we first need to move what is not connected to the variable. Okay, so which term between 3x plus 15, which one is not connected to x? 15. So we move that one first. How would we move 15 to the other side? Anybody have an idea? How would we move it? You would subtract it, right? Subtract 15 from both sides. Subtract 15. And now you rewrite the equation. Are you guys writing this down in your notes? Okay, rewrite the equation. 3x equals 9. And when we write it like that, and when we're looking at the equation, it's a lot easier to see what the next step would be. Instead of maybe trying to do it mental math, what would the next step be to solve for x now? Sarah? Divide by 3. X equals 3. X equals 3. Can I check this? Could I check it? All right, how do I check? Plug it back in. Could we do this mental math? 3 times 3 plus 15? Yeah, it's simple enough. 3 times 3 plus 15 is, yes, 24, so I know my answer is correct. And guys, if it's not easy to do mental math, just plug it in your calculator. All right, so checking is just a real quick practice that we can do just to make sure that we got the correct answer. All right, go ahead and write down the next equation. 1/2 x minus 9 equals negative 25. Go ahead and write that one down. And as you're writing it down, I want you to think, okay, I want you to think, what would be my first step? So what would you do first? What would you do first? What do you think? I know somebody knows. Just tell me. You're going to add 9 to both sides. Very good. Add 9 to both sides. And now that the 9's cancel out on the left side, what's left? What do I bring down? 1/2 x equals, okay, I got to be careful. What do you see here between these two numbers that I'm simplifying? A positive and a negative. So do I add them or subtract them? Subtract and take to make negative 16. Okay, we talked about this on Tuesday. Does anybody remember, how do I get rid of a fraction that's connected to the variable? Sherelle, do you remember? How do I get rid of a fraction? Yes, do the reciprocal. Very good. Okay, so if it's 1/2, what would I multiply by? 2 over 1. Okay, now not x, because I want x to be by itself. All right, multiply this side by 2. Negative 32. Can I check this? Yeah, it might be, you know, take a little more thought than the first one, but what's half of negative 32? Negative 16 minus 9 is still negative 25. Okay, so yes, negative 32. So that's example 1, solving 2-step equations. Any questions on that? Or, so, yeah, example 1. All right, before we do example 2, I need to review a concept with you guys. Concept called combining like terms. You guys remember combining like terms? You learned it last year in chapter 7, I think. So like terms either have the same variable or they're a number by itself. Okay, so what do you think? Is 2x plus 3x, are those like terms? Do they have the same variable? Yes, they do. So anytime two terms have the same variable, I can add their coefficients. Remember, the coefficient is the number in front of the variable. You guys remember that term from last year? Okay, so when I say coefficient, I mean the number in front of the variable. So what's 2 plus 3? 5, and then you keep the common term, x. All right? Okay. 5x. All right, what about 2x plus 3y? Are those like terms?
No.
Can I combine them at all? No, I can't. They're not like terms. It's just 2x plus 3y. That's it. All right, so even if it's a variable, that doesn't matter as much as is it the same variable. All right. What about negative 7a plus 3a? Are those like terms? Why would you say no? Because one's positive and negative, okay? Good observation. But that still doesn't make them unlike. Do they have the same variable? Yes, so they are like terms. So as long as it has the same variable, the sign does not matter. I can do negative 7 plus 3, which is negative 4a, okay? Did that clear up maybe some questions? All right, so the sign doesn't matter as long as it's the same variable. What about negative 12 plus 2? Are those like terms?
Yes.
Neither one of them have a variable. They're both numbers. Could I combine those together? Yeah. What's negative 12 plus 2?
Negative 10.
Negative 10? Okay, so if it's a number by itself, absolutely, I can combine those. What about the last one, negative 10 plus 2x? Can I combine? Why? So one has a variable and one doesn't, so I cannot combine them. All right, so does that help a little bit? Does that kind of refresh your memory on what you learned last year on combining? All right, so what we're going to do now is solve equations by combining like terms. So let's look at the first equation. 8x minus 6x minus 25 equals negative 35. I want you to write that down on your notes underneath example 2. Okay, so here's one hint or clue that I might have something to combine. How many terms do you see on the left side of the equation? How many terms? There are 3 terms, 8x, negative 6x, and negative 25. Anytime you have more than 2 terms, that should kind of set off a little alert for you that you have something you can combine. Which 2 terms can you combine? 8x minus 6x. So what's 8x minus 6x? 2x minus 25 equals negative 35. All right, so I'm going to make your homework maybe just a few seconds faster for you. If you see an original problem that has combining like terms and you want to go ahead and combine it and write this as your original problem on your homework, you can. Right, so if you're reading the problem in your homework book and you say, oh, I can combine those, just write it. Just go ahead and write it as your original problem. Okay, so now I combine my like terms and now I'm back to example 1. Right, in example 1 I solved a 2-step equation that looked just like this. So you see how example 2 just kind of stacked that extra step at the beginning? We combine our like terms and now we're back to where we were working in example 1. All right, so go ahead and solve for x. 2x minus 25 equals negative 35. Okay, what was your first step? What did you do on your first step? Add 25, very good. Add 25 to both sides. Why? Because that's the term that's not connected to 2x, right? You guys see that? Did everybody get that part? Okay, so 2x equals negative 10. Wait, is it negative 10 or negative 60? Why is it 10? Why did I subtract instead of add? Different signs. Very good. Okay, so you guys are doing well with that. All right, so now what do I do to both sides? Divide by 2. And x equals negative 5. All right, who got that right? Got that right. Good, good. If you got it wrong, do you see maybe you just made like a little mistake, or do you see where you went wrong? All right, let's do the second one now. I'm going to walk around. I want you guys comparing your answers in your groups, okay? So I'm going to just kind of check on you guys and see how you're doing. Okay, negative 4 minus 8 is negative 12n plus 17 equals 23. Subtract 17 from both sides. Did we all do that? Negative 12n equals 6. All right, and this is where we often get tripped up because we see, oh my goodness, I just divided by negative 12 and that is not going to be an even number. So even in our minds we think, oh, I just need to reverse it and my answer is 2 or negative 2. But we can't ignore the fact that that's a fraction and our answer is going to be a fraction, and that is okay. And a lot of our answers are going to be uneven numbers, fractions, decimals. It could, look different, okay? And that's fine. All right, that's example 2. Any questions on combining like terms, solving? I think you guys did really well on that. Okay, moving on to example 3. We're solving using the distributive property. The distributive property. All right, so the distributive property we know is one of our number properties. So we're going to review what that is. I just need you guys to kind of title the example, example 3. Okay, so distributive property, like I said, we're just going to review real quick. All right, if I gave you an expression 2 times x plus 3, so we just talked in the last example of how we cannot combine terms like this, x plus 3, they're not like terms. So we've got kind of a problem here in that we need to get rid of the parentheses, but we can't combine what's inside them. So here's what we do. We distribute it. 2 times x and 2 times 3. We multiply it. Even though there's an addition sign here, we don't add them. We multiply each term inside the parentheses by the term on the outside of the parentheses. So what would be 2 times x? 2x. What's 2 times 3? 6. And now the parentheses are gone. I've now distributed. Basically what I've done, guys, is I've multiplied 2 into those terms. Does everybody agree that 2 is now a part of 2x? And 2 is now a part of what was multiplied by 3? So basically, it's a part of that term now. Does that make sense? 2x plus 6. What about this one? Negative 3 times 2x minus 2. So now I've got a negative on the outside. Does that change anything? Does that change my process? No. What's negative 3 times 2x? Negative 6x. I multiply the coefficients. Remember that word that we just learned? I multiply the coefficients. Negative 3 times 2. Negative 6x. What's negative 3 times negative 2? Positive 6. You see, guys, we don't add them or subtract them. Even though there's a minus sign there, we're multiplying. All right, that's the number one mistake that I see. Okay, let's try this one. Just because it's a decimal, does that change my process? All right, and you're going to see that. Decimals, fractions, all right, they put it all in there. Negative 1.5 times x. Negative 1.5x. Negative 1.5 times 2? 3 or negative 3? Negative 3. Okay. All right, so does that look a little familiar to you now? A little more familiar? Okay, distributive property. So now we take distributive property and we go back to example 3. And now we're going to use the distributive property. First step in order of operations is what? What do I do first with order of operations? Get rid of the parentheses. How do I do that here? I use distributive property. Okay? So let's write down this equation. 2 times 1 minus 5x plus 4 equals negative 8. Go ahead and write that down. All right, so what would be 2 times 1? 2. What's 2 times negative 5x?
Negative 10x.
Okay, does everybody understand what we just did? So now we bring down the rest of the equation. Okay, and now, okay, I've got an alert kind of going off because what do I see here? 3 terms, so what does that tell me? I might have something to combine. Do you see anything we can combine here? Very good, the 2 and the 4. Wait, though. Is it 2 minus 4, or is 4 positive? 4 is positive because that's the sign in front of the 4. The negative belongs to what term? The 10x. So we have to pay attention to the sign in front of that term. It's 2 plus 4, which is what? 6. 2 plus 4 is 6. Minus 10x equals negative 8. All right, and now I can solve my 2-step. What would I do next? Do I add 6 or subtract 6? I subtract because it's positive. All right, now I've got to be careful of one other thing. I've got negative 8 minus 6. What do I do here? I add and keep the sign. So negative 10x equals negative 14. All right, so here we resist the thoughts of, oh my goodness, this isn't going to work out, so I got it wrong. Doesn't mean that you got it wrong. Doesn't mean that it's wrong because it's not a whole number. In this case, it's just going to be a fraction. That's okay. What do I divide both sides by? Negative 10. And x equals? Is it negative 7 over 5 or positive? Why would we say positive? Yes, because we have to remember our rules for division say even number of negatives that I'm dividing is a positive answer. Okay, so dividing 2 negatives would make a positive answer. All right, so we do need to keep those rules straight. All right, go ahead and do the next one. I want you to work it in your groups and compare your answers. Raise your hand when you have your answers or if you need help. So a common mistake that I'm seeing is, did you add first? I know a couple people, I saw your paper. We don't add first because order of operations says we have to multiply. You have to get rid of our parentheses first. So we're just going to bring that 5 down. 5 plus, what's 1.5 times 2d? What's 1.5 times 2d? A couple of you had it. 3d. What's 1.5 times negative 1? Negative 1.5 equals 0.5. Okay, I see 3 terms. Which terms can I combine? 5 and negative 1.5. So what's 5 minus 1.5? 3.5 plus 3d. Oops. Equals 0.5. All right, if you haven't finished yet, go ahead and finish solving. Okay, I'll just give you a couple seconds to go ahead and finish up this problem. Now that we've distributed, now that we've combined our like terms, now let's finish up and do our steps. 3.5 from both sides. What do you get? 3d equals negative 3. Divide by 3. And d equals negative 1. All right, who got negative 1? Okay, good. All right, so are we kind of catching on? Are we catching on to this? All right, so really, guys, examples 1, 2, and 3 really just stacked on top of each other, okay? So if you don't understand, you maybe go back tonight, watch this YouTube video, okay? And that can help you. All right, one more example, example 4. Find the number of miles you need to run on Friday so that the mean number of miles run per day is 1.5. All right, does anybody remember how to find the mean? How do you find the mean? Anybody remember? Yes, Mason? Yes, yes, very good. It's the average. All right, so did you hear what he said? To add them all up together? Okay, so we add each day together. Monday, Tuesday, we slacked off, right? No miles. Wednesday, 1.5 miles. Thursday, slacked off again. So, did a lot of slacking off this week, huh? all divided by, what would I divide by to find the mean? What do I divide by?
5.
Okay, we divide by 5 because there were 5 numbers in the set. All right, and that equals, what does it want my mean to equal? 1.5. Okay. All right, so here's what we do. I'm just going to tell you because this is new to you, so I'm going to show you the first time what we do here. We need to first see if there's anything we can combine. There's a lot of numbers up here. Is there anything we can combine up there? 2 and 1.5? Okay. All right, so that makes 3.5 plus x over 5, and that equals 1.5. Okay, so in the past, we try to get rid of fractions by multiplying by the reciprocal. Here, we can't do that because there's a plus sign here connected to x, not multiplication, but we can get rid of the denominator. We can cancel our denominator by multiplying both sides by 5. Remember what our multiplication property of equality says. As long as I do an operation to one side and do the same thing to the other side, I don't change the value. So this is allowed. I can do this. Multiply both sides by 5. What am I left with now? If I multiply both sides by 5 and cancel my denominator, what am I left with on the left side of the equation? Okay, I'm left with 3.5 plus x equals, and I heard it, Mason, what was it? What's 1.5 times 5? 7.5. All right, so I'm really close now to figuring out what x needs to equal. How can I solve for x? How can I get it by itself? Minus 3.5 on both sides. All right, so I slacked off all week. I didn't do any running at all, hardly. So if I really want to hit my average of 1.5 miles, how many miles do I have to run on Friday? 4 miles. Okay? And that's in order to have the average that I'm looking at for. All right, do you see how we kind of put that together? Really, guys, it comes down to setting up those equations. My total goes on one side. Combination of the other information goes on the other side. I just have to figure out what that is. The key word here was mean. That told me I was finding average. All right, so that really gave me a good head start. If you understand that, that's everything you need to know for section 1.2.